Welcome everyone. Today we are going to discuss about the UMTS interview. In these sessions, we are going to discuss the more detail about what are the most possible questions we'll ask in interview. And I believe that once you prepare with the sessions, you can clear any kind of interview which happens in UMTS. 95% of questions which the interviewer will ask for a drive test engineer when they are going for a job, these are the most important, and they give you a concrete preparations in order to clear your interview. So without any wasting time, let's do start our sessions and see like what type of questions and answers will be there in UMTS interview sessions today. If we talk about what is the maximum UE transmit power in your link budget is 21 dBm. It's a very simple, like 21 dBm the mobile will transmit the power in uplink whenever it's getting connected with the network. What is a typical antenna gain? This is our most common questions we'll ask, but this antenna gain depends upon the antenna model, what type of model we are using. But in the link budget we use around 17 dBi. This is our antenna gain where we have. What is the difference between the dB and dBm where we have it? So dBm is the unit of power level measured in milliwatt in algorithm scale. dB is not a unit, it's a difference of in dBm where we can say it. What is processing gain? It's a processing gain in the ratio of chip rate over the bit rate where we get it. So usually represented a symbol scale, so where we call as a processing gain, as we have discussed in sessions also about the processing gain. What is the UMTS chip rate? Is a 3.84 mega chips per second where we have it. Over the 5 megahertz of bandwidth we utilize only 8.4 megahertz bandwidth. How does the TMA work? TMA stands for the tower modulated amplifier. It's reduce system noise, improve the uplink sensitivities, as well as it leads to the longer UE battery life. Sensitivity in the minimum input power needed to get suitable signal to the signal to a noise ratio at the output of the receiver. So TMA typically has a 12 dB gain here. So there are typically top jumpers, mean feeders, and bottom jumpers between the antenna and BTS with this TMA will be used. What is RSCP? RSCP is similar like RX level, where we have in 2G we call as a receiving level, in 3G we call as RSCP. The received signal quote power, the energy per chip in CPI/CH for common point channels which average over the 512 chips we are receiving, that is shows the RSCP. What is E by naught? By the definition of E by naught is an energy bit over the noise density. That the ratio of the energy per information bit over the power spectrum density. That is we call as interference noise after dispersing the signals, where we call as E by naught. If we come back to the SIR, what is SIR? Is a signal to interference ratio, the ratio energy in dedicated physical control channel bits over the power density of interference and noise after dispersing. So what are the noise and interference will be getting added to the signals? That is we call as the dispersing. After dispersing we get this. How many type of handovers are there in UMTS? It's a very simple. We have it soft handover, softer handover, interfrequency handover. In the case of interfrequencies, like when we have a dual frequencies, so it's handover from one frequency to another frequency, that is we call as an interfrequency handover. We have inter-RAT handover. Inter-RAT is radio access technology. When we are having the handover from one technology to another technology, that is UMTS coverage to the GSM coverage, that kind of handovers we call as IRAT handover or inter-RAT handovers. Inter-RAT cell changes, also in ideal mode you can change the cells also, so that is we call it the cell changes here. So you move in out of the UMTS coverage into the GSM GPRSH coverage area, that is we call as cell changes in IRAT. This is what happens in it. What is the soft handover and softer handover? If we talk about the soft handover, when UE connected to two cells owned by a different node, and softer handover is nothing but the handover when the UE connected to the cell owned by the same node. What does it mean by that? If I talk about the soft handover here, let me explain you like soft handover how it would be like. So imagine this, we have one base stations, we have at a certain distance we have another base stations. Let me draw somewhere here. So let me draw here. So when I'm, this is my sector, this is my sector, this is a cell site which gave the coverage. So the UE is connected in between this cell, so I'm connected with this cell, so I have one active set here. So this is my one active set from this cell. So when I find my UE find, this is a strong cell and it should also be take the handover, so it will not break the link from this cell, it make the link from another cell. So this are the process we call a soft handover. It happens usually between the two different base stations, so that is we call it a soft handover. If I talk about the softer handover, it's nothing but like whenever the handover happens within the base station but the different sectors. So that is intra BTS handover kind of things, like same BTS but we are having two cells of that same BTS where the handover processes happen. This type of handover we call as a softer handover when the UE is connected to the cell owned by the same node. Now, what is a typical EIRP? So this is nothing but equivalent isotropical radiate power, which is depends on the node B transmissions power, which is measured based on the planner decide what would be that. It's based on cable and connector losses and antenna again how much, based on that the EIRP will be given. How much power usually node B is allocated to the control channel? As we have discussed, we have a control channels and dedicated channel. So in this case, how much power will allocate to the control channel here? The power allocated to the control channels may depend on the equipment vendor recommendations. Nokia has something, Ericsson has something, ZTE equipment has something, Samsung has something. So based on their equipment, but typically there is no more than 20% of node B power is allocated to the control channels. And in case including the CPICH also, in case if you are taking the HSDP over the same carrier frequency, at this point the total power allocation to the control channels go up to 25 to 30, means like the additions of 5 to 10% which is there for the HSDPA control channel, because there is no additional we require the additional control channels for operating the HSDPA. That is reasons where we have 5 to 10% which is added here. What is typically CPI-CH power? We call as common point channel. So CPI-CH power typically take out of 10% of total node P power. For example, let us take it for 20 watts allowed 43 dBm node P power. So CPI-CH around 2 dBm. But in urban area, which in building coverage, like we can also call as IBS in building installations where we have it. Okay, the CPI-CH may be sometimes go low as 5%, because users are very closer to the cell site, so the coverage area is small since user also very close. So at that time it can be allocated to the traffic channel as this much power. What is the channelization code? As we have discussed already, the channelizing codes are the orthogonal codes. What does it mean by the orthogonals? That is nothing but non-interferencing. So used to spread the signals and hence provide the channel separations. That is, channelizing codes are used to separate channels from the cell. Now if I talk about the scrambling code and how many scrambling codes are there, scrambling codes are used to separate the cells and UE from each other. That is, a cell of or UE should have a unique scrambling code, and there are 512 scrambling codes are there in the downlink and millions of in on the uplink, as we have seen 2 to the power of 20. That is, we call it the gold sequence like this, where we have uplink which is decided by the RNC uplink codes. What is the scrambling code groups? So the scrambling codes are divided into the 64 groups, and each group consists of 8 scrambling codes. I don't want to go ahead and deep and explain you about all each group and codes, because it will be a lengthy process. Again, you will be in confusion. So this is a simple answer. It consists of 64 groups and each group consists of 8 classes. How we divide the scrambling code groups into the subgroup and give an example. So it's very simple. Yes, we can divide this with the 64 groups into the subgroups. We have a micro cell, micro cell, we have nano cell. So based on that, so when we talk about the micro layer group, where we have a 24 group are reserved. If we talk about the micro cells that are outside BTS, in that we have it 24 groups which are allocating. If we talk about the micro layer, that group of 16 cores that reserved for in-building sites, and rest of 24 groups which are left, that is are for extensions, like when you want to expand the sites and all, where you can use it. What is the pilot pollutions? Very important question. You're going to 100%, not 100%, I can say that 200% these questions will ask if you're there in interview. This is a very important question. What is pilot pollution? So simply speaking, when we call as the number of strong cell exceed the active set size, there is a pilot pollution in this area. Typically, the active sites is maximum 3. So we should get active sites are 3. But if we are getting more than 3 strong cell at this area, that is we call as pilot pollution. So we have AS1, AS2, AS3. This is a normal conditions where the UE can get. If we are getting more than this 3, that is we call as pilot pollution. What is compressed mode? Now, as guys we have discussed just now, ki whenever the 3G coverage are going bad, when the 3G coverage goes bad and the mobile is moving and we are getting the 2G coverage is strong, so mobile has to give the handover to 2G network, that is we call as a IRAT handover. So when the IRAT handover happens, before that the mobile have to go to the compressed mode. Before you perform interfrequency or IRAT handover, it need to have some lock on the control channels of their frequency or the system and listen to the broadcast information. So the certain ideal period are certain as a radio frame for the purpose of this called as a compressed mode. So before performing the IRAT, the mobile has to go to the compressed mode to scan the frequencies. Describe the power control scheme in UMTS. So open loop power control, where we have a loose closed auto loop power control where we have it. If we talk about the open loop power control here, for UE to access the network, that is used at the call setup or initial access to the UE to transmit some power, that is we call it the open loop power control. Whatever the power allocation to the user to transmit their request or initiate the request or access attached happens that time, that open loop power controls work. If we talk about the closed auto loop power control, RNC calculate based on the SIR, that is the target SIR, threshold SIR, and sends the target to the node B every 10 milliseconds of frame where this happens. So this is we call as open loop and closed loop power control. What is cell breathing? The cell coverage shrink at the loading interface, so it's calculated as it's called as a cell breathing. So in uplink, as more more UE is served by a cell, and each cell need to be transmit higher power to compensate for the uplink noise raise. That is point we call as cell breathing. So sometimes what happens, like there are been coverage shrink happens, you may know that, like that type of process we call as a cell breathing. What are the interface where we have in UTRAN network? What are the components we have? So user equipments are getting communicate with the node B. User equipment also we can say as a mobile stations when it's getting communicate with the node B, we call as a UU interface. We have IUB interface which are there between the node B and RNC. So this is we call as a IUB interference. Two RNC get communicate each other with the help of IUR interface and IUCS interface for the packet, and also we have IUPS interface or IUCS interface which can be take RNC to MSC, which we have already discussed in clear concept about. So when the packet requests there IUPS, if there is a circuit switch IUCS interface. Briefly describe about UMTS frame structure. It's very simple. UMTS frame duration is 10 milliseconds. Each frame is divided into 15 time slots, 0 to 14, and each time slot is divided in 2560 chips here. And so if we have a 15 frames, so those are 38,400 total chips are there in a one UMTS frame. What are the three type of sets in the handover? So it's a 100% askable questions. What type of sets you'll observe? So there is an active set, monitoring set, and detected set. Active set is something with the list of cells which are in soft handover to the UE, means like which the UE is connected to also, we call as active set. Monitoring set, the list of cell which is non in active set but the RNC has told the UE to monitor, that is the configured neighbors, the sites which are the neighbors which call as MN here. The sites which are not neighbor but we are getting the signal, that is called as a DN here, detected list cells. So list of cell detected by the UE but not configured in the neighbor list, that is we call as DN. What are the major difference between the GSM and UMTS handover decisions? Very important to know that. The time-based mobile measure of RX level or RX quality, the mobile sends this measurement report every such period of 480 milliseconds. Means like every 480 milliseconds, a measurement report sends to the BSC. Based on that, the instructions will get from BSC to the BTS for the handover based on this report. But in the UMTS, it not happens based on this such report or any measurement report. It happens based on the events. There are the event triggering. So report UE sends a measurement report, that's fine, but on a certain event triggers this happens. So UE plays more part in the handover decisions, which cells should be added, which is to be removed based on these conditions where the events happen. What are the type of events we have? We have 1A, 1B, 1C, 1D, 1E, 1F, like this we have it. Let us talk about 1A event. 1A event is nothing but whenever any cell is there. Let us see, like we have one AS, we have MN, we have another MN, we have some other MN. Now this AS is an active set, right? Now this is an active set. Let me type, let me write the scrambling code here. Let us see, this is a 49. Let us see, this is 50. Let us see, this is 52. Let us see, this is 55. So this is the scrambling code. So when we find that the scrambling code 50 cell is getting strong, means like we need the handover from this cell. So when we need the handover, we need to add this cell, right? So when we are adding this cell, the first event happens, the event 1A happens. So a primary common point channel enters into the reporting ranges that add a cell to active cell. So this MN is getting added to the AS. So this AS, now this become, there is no MN now because it become as AS. So 50 become AS. So we have 2 MN only left here. So this is the type of event we call it. So the event is nothing but which used to add the cell. So a primary common pointed channel enter into the reporting ranges to add the active cell. So when the active set is full for UE, we stop reporting to one event. 1B, a primary common pointed channel leaves the reporting ranges, that is removing a cell from the active set. So if any cell is going bad, it has to be removed. So that is happens with the help of 1C event. Oh, sorry, 1B event. If we talk about 1C event, a non-active primary CPICH becomes better than an active primary CPICH, that is nothing but replacement. So it's nothing but when we talk about 1C here, let's have a look over here in the 1C. Whenever when we are comparing that the 52, let us see the scrambling code 52, this MN is getting better than the threshold value of whatever the threshold value is there, is getting better than that value, and this AS is getting somewhat bad here comparing with this MN. So it's time, if the 1C event happens, 1C events happens means it has to remove. It has to, 1C event is nothing but it has to remove. Now what it has to remove and what should it has to add, because it is a replacement cells, right? So at this case 1C when happens, we remove scrambling code 50, we add scrambling code 52. This process we call as a replacement. So this is a non-active set. This is a non-active set, is becoming a better than the active set. So a non-active primary CPICH becomes better. It becomes better than an active primary CPICH. So it replaces the cells. So this is our, we call as the replacement process, which happens with the help of 1C event. If we talk about 1D event, based on active sets, suppose we have 3 active sets, so which is a high priority, which is get changes to that. So that is we call as a 1D event. 1E event, a primary common pilot channels becomes better than the absolute thresholds, we get it 1E. 1F, a primary CPICH becomes worse than the absolute threshold value. So it's going very bad, worse conditions, we get it this way. So there are 2A, 2B, 2C, 2, 3. There are different events are there. This is our most common in events which happens. You're gonna see a lot of events when you're going for the drive, but out of a lot of events, these are the most happens events which are there in the field. So hope you understand about this. Let's go to the next questions here. What may happen when there is a missing neighbor or incorrect neighbors where we have it? If we have a missing neighbors or incorrect neighbors at this point, there is a access failure or handover failures, may attempt to the access to the wrong scrambling code, or there may be a drop call. So you are not aware of the strong scrambling code which is getting, so interference also will be there. So poor data throughput, poor voice quality, this is are the things which happens when we have missing neighbors or incorrect neighbors. What are the conditions that you may typically set to a trigger irate handover? So that means like whenever we are happening the irate, what is the reason? How the engineers has, how the operator has planned when the irate should be happen. So in order to count that, like we have the RSCP, whenever it's going above -100, above -100 dBm, whenever it is going, there is a chance of irate handover, as well as if the econo or ECI by naught or EC by I naught both are same, when it is going above -16 dB. So it started from the 15. So once this goes above -100 or -16 dBm, there is a chances of happening the events we call as a compressed mode, where there is a possibilities of irate handover. So what typically event happens when the irate happens? So that is a very important part which we know. So event happens when the irate is happening 2D, as we discussed the compressed mode in the previous process. So compressed mode happens with the help of 2D event. So 2D enter into the compressed mode measuring 2G network here, 2G cells here. So 3A event is also there, which verifies the 2G resources for the handover from UTRAN network to the GRAN network. So command from the UE which will send it over here. So this is the process which happens in the irate process. Hope you clear this. What are the possibility of irate failure? So reason why the irate failure can be happens that missing of 2G relations, 3G relation, 2G relation is not defined. Obviously there is a irate failure. Non-availability of 2G resources, poor 2G coverage, or missing the 3G relations. So 2G relations or 3G relations missing, 2G coverage is poor, or 2G resources are not available. So this is the reasons of irate. What are the possible causes for the drop calls on the UMTS? 100% this questions will ask. You must know about this. So poor coverage in uplink and downlink, pilot pollutions, pilot spillover, so missing neighbors, scrambling code collisions, delay in handovers also can be there. Low resource availability, congestions for the handover, or in loss in the synchronizations, fading, fast fading, delay in high irate triggering, hardware issue, or some external interference. So this is the some of the reasons for the UMTS call drop. What is the difference between 2G and 3G network, as we have discussed already, but let us have it this, and may I ask you this question. As we know, the carrier space is 200 kilohertz in 2G. In 5G we have 5 megahertz. Frequency reuse is 1 to 18, 1 to 20, depends upon the available frequencies which are there in GSM. The reuse factor is 1 only in 3G. Power control which happens 2 times in a second in the 2G technology. In 3G 500 times in a second, that is we call as a fast power control. We have the control, quality control by the frequency planning. We need to plan the frequency in a proper manner. We should not get interference. In 3G we have radio resource management functions with the power control and code planning, where we have to measure this quality maintain, and also we have a planning. In GSM we have frequency planning, or in 3G we have code planning, that is a scrambling code planning, where we have. What is the effect of pilot pollutions? Effect of pilot pollutions are high blur, low system capacity, high call drop due to frequent handovers from different cells, and the low access rate due to the number of dominated cells are increasing in that area. So this is the reasons for the pilot pollutions. Well, we can see. How to reduce the pilot pollutions? very is important. So maximum signal inside the best server minimum energy to overshoot from the neighboring cells. Means like the stronger signal from the other cells which are overshooting neighboring cells. That is the reasons the mobile is getting access to the as much as active sets here. So RF conditions are very good with the different neighbor cells also, which should not be there. We are getting their coverage. So there we have to optimize, physical optimize with the tilt and azimuth, where we can minimize. So proper transmit power and proper power ratio of the site are probable solutions for this problem. What are the typical KPIs we use to measure the network, and what are the criteria are there? So this is the KPI. First of all, let me explain you what do you mean by the KPI. KPI is nothing but we call as key performance indicator. It's like a health report to the network. Like whatever the task happens, how many calls are attending, what are the calls are getting dropped, how many handovers happens, all this process which is measured by the KPI, key performance indicator. This key performance indicator is nothing but which give the complete health report about network, what is the performance level of it. Like we have our own health report, the similar way network health report is KPI. So in that, access failure rate should be less than 2%, call setup time, how much calls out. So these are the defined based on SLA between the operator and the equipment companies. So the call circuit switch call over the 95% of the time, like in that 6 second for the mobile to the PSTN network and 9 seconds from mobile to mobile. Here the call setup time, usually it happens within 2 to 3 seconds. This is the time, but the threshold value, it's based on the, it may vary also. PS over 95% of the time, which is 5 seconds also we can say. Drop call rate should be less than 2%, and blur block error rate, which we consider as like 95% of area where we consider of less than 2%. So this is the interview process which may ask in UMTS. Hope you understand. This is good enough if you're perfect with this.